All right, so today we're talking about our product rule, okay? In math, product means multiply. So product rule is when we're multiplying exponents. We're gonna start off easy. We're gonna go through like 3 or 4 examples together. You guys do have some practice on this. Make sure that we're good to go, and then we're good to go. So the first basic rule of product rule is when we are multiplying exponents with the same base, we add the exponents, okay? So let's go through a few examples. Okay, so you have x to the fourth times x to the fifth. X to the fourth times x to the fifth. We're multiplying. The bases are the same, both x. So we're going to add the exponents. When we add our exponents, this guy turns into x to the ninth. All right, guys, stop in the chat or else I'm going to disable chat. Let's go. Okay. So general rule of thumb, multiplying two exponents, two powers with the same base, we add their exponents. Okay, what happens when numbers get thrown in? So let's say we have 6x to the third times 2x to the fifth. Okay, this is a little different because these are called coefficients, the numbers attached to our powers. Okay, so what we do here is with the exponents, the piece of the power that's just the power, the base to the exponent, we add those exponents, but the numbers get multiplied because we're just multiplying here. So 6 times 2 gives me 12. And then the x's turn into x to the eighth because we add those powers. So we multiply the numbers, add the exponents. Okay? Any questions on that example? Okay. We're going to go through like 2 more examples, make sure we're ready to rock, and then I'll let you guys fly with the practice for today. All right. Here's another type of trickier example, okay? Let's say we have 4x to the third times 6y to the seventh, okay? This one's tricky because our two powers here, x to the third, y to the seventh, the bases are different. So we cannot add the exponents because the bases are not the same base. We can only add the exponents when the bases are the same. So to simplify this into one expression rather than two separated expressions, we're going to start by multiplying the numbers because, again, it's just multiplication. So 24. And x's and y's, like I said, don't have the same base, so we can't put them together. So they just stay separate. Okay, so the numbers still get multiplied together. X to the third stays x to the third. Y to the seventh stays y to the seventh, but they just turn into one term rather than two terms multiplied. Okay, any questions on number 3? Any questions on number 3? Okay, our last example is going to be number 4. So let's say we've got 7x squared, y to the fourth, z to the negative second, times 3y squared, z to the fourth, and let's throw in a. Okay, so this one's tricky. There's a lot going on. We've got numbers, we've got x's just over here, we've got y's in both, z's in both, and we have an a in this guy. So let's start with our numbers. Remember, we're multiplying, so we multiply our numbers. So 7 times 3 is 21. X has no friend to combine with, so he just floats. Y to the fourth, y to the second, add those exponents because it's multiplication. We get y to 6. Z to the negative second, z to the fourth, add those two exponents. Even though this one's negative, we're going to talk about negatives next week. Negative 2 plus 4 is z to the second. And a has no friend, so a just stays a to the first or a. And this guy is completely simplified. By the time you're done, you should only have one of each letter. 1x, 1y, 1z, 1a. Versus up here, we have 1x, 2 y's, 2 z's, and 1a. Okay? The number should be simplified as well. 2 numbers become 1 number by multiplication.